Let's take a look at a problem involving a horizontal axis of rotation. In this particular problem, we're trying to find the volume of the solid of revolution. It's obtained by rotating a triangle with the vertices -1, 2, 0 to 1, and 2, 2, and we're revolving it around the x-axis. So I'll draw a real quick sketch here. My x-axis is down here, and I'm revolving the region from -1 up 1, 2, 0, 1, and out 2 and up 2. So here is my rectangle. Now, let's note that it would be difficult to do this problem using the washer method. If we have a horizontal axis, it might be tempting to pick an x value and do a washer method, like so. The problem is this inside radius right here changes if we pick the x value on the left of the y-axis. If we pick this x value instead, the function for the inside radius changes because it's a different curve on the left than it is on the right. And so we'd have to split this into two parts. I'd have to take care of the left part and then I have to take care of the right part separately and then add up those two volumes. And I just don't want to do that. That sounds like a lot of work. So what I'll do instead is from scratch draw this, and instead of fixing my x value, I'll fix my y value. So again, we'll draw the picture. So we have 0, 1, -1, 2, and 1, 2, up 2. So here are 3 points on the triangle. I've got a horizontal axis of rotation. And instead of picking an x value and taking that rotation of that line segment like so, I'll pick a y value. Pick a y value right here. And if I extend that to all the points in the region with that particular y value and revolve that, I sure enough get a cylindrical shell. Now with a cylindrical shell, it's at this value of y right here. I need to know two things about it. I need to know the radius of the shell, the distance from the axis to the side, and that would be a function of y. And I also need to know the height of this shell for that particular y value. Oh, excuse me, that gave the height of the outermost y value, but for the way I drew the picture, the height would be the distance to that point there, from this point here to the top of the shell here. So that's all well and good. How do I figure these out? Well, I'll do the easy one first. The radius is just the distance from the inside the axis up to the outside of the shell, and that's y tells me exactly what that is. That's just going to be y. So that's no problem at all. The trickier part is going to be figuring out this height. Now what I could do is I could split this up into two parts because I've got the part of the height accounted for by taking from the y-axis up to the right point, and that's given to me by this curve here. So this part of the distance would come from the x value of this point right here. So I know the y value, so to figure out what the x value is, I'll just take the equation of this line. It's a line as a slope, rise of 1, run of 2, so that'll give me 1/2 x, and the y-intercept is 1. But we need to remember that this is y as a function of x here. We're wanting x as a function of y, so I'll solve for x. That gets me that 1/2 x is y minus 1, and x is 2y minus 2. So 2y minus 2, because this ordered pair would be 2y minus 2 as the x, comma, y. All right, so there's my x value right here, and that's no problem. And so it would stand to reason that we could do a similar trick to figure out this other part of the height. To go from this y value out to this point, we'll need to use this curve. So for this curve, I'll just do the same trick. I know that y is equal to, I've got a slope of -1, negative x, y-intercept of 1, plus 1. And I'll solve that for x, and that's going to be 1 minus a y if I solve for x. Now here's the problem. It's very tempting to just take this and stick it right here. But is this distance really the same as x? Well, x is negative at this side. So what I'm really looking for is negative x, because the distance from 0 out to this negative x value would be the positive version. So I'll multiply it by negative, giving me y minus 1 for this left side of the height. And that's very tricky, so we have to be vigilant in looking out for those negative x and y values. But now that we've figured it out, we can just add y minus 1 with 2y minus 2, getting me 3y minus 3. And that's my height right there. So I've got my radius, y, my height, 3y minus 3. And so we'll take it all together into the volume formula. Now, what do I integrate over? Remembering that these are y values now. I picked y values here. I need to go from the bottommost y value, 1, to the topmost, 2. You always go from lesser to greater y values because you want to be increasing your y when you integrate with respect to y. So we'll go from 1 to 2. We can go ahead and factor out the 2 pi, and we'll have the radius times the height. The radius is y. The height is 3y minus 3. Let's factor that out, or multiply that out, I mean. So 3y squared minus 3y with respect to y. And we integrate to get y cubed minus 3 halves y squared from 1 to 2. So we'll plug in the top. We'll get 8 minus 3 halves, 2 squared is 4, minus, plug in a 1, we'll get 1 minus 3 halves. So cancel here and here. So that's 8 minus 6 is 2. 1 minus 3 halves is negative 1 half. So we have 5 halves times 2 pi is 5 pi. And that will give us the volume of this region, this solid of revolution shown above.